So we now have another problem. An open box is to be made from a 16 inches by 16 inches piece of cardboard by cutting equal squares from each corner and folding up the sides. For maximum volume, what sizes should the square be cut? So we are being given a square made of cardboard, and we are going to cut squares also from each of the four corners. And after cutting those squares from each corner, we are going to fold the sides in order to make a box. So here's an illustration. We have a square 16 inches by 16 inches. We are going to cut small squares in each of the four corners. Once we remove these squares, we are going to fold it. We are going to fold along the dotted lines. And once we do that, we will have an open box. So since this is a three-dimensional object, there is a length, there's a width, and there is a height. This is also called a rectangular prism. And in a rectangular prism, you can always find the volume. The formula for volume is length times width times height. And if you remember, the problem said we need to maximize the volume. So therefore, f of x should represent the volume. We have to express, however, the length, the width, and the height in terms of x. Let's look at again our illustration. X is going to represent the dimension of the squares that we are going to cut. If we are going to cut a square in every corner, then naturally the side length will not be 16 inches anymore, because we are going to remove one square from the top and another square at the bottom. So therefore, the measurement 16 inches will decrease according to the dimension of the x that's going to be removed. So what should be the dimension at the left side of this figure? I hope you can see that this is now 16 minus the 2x that we removed. And same thing will happen to the dimension at the bottom of this figure. If you go back to our illustration for the box, the length now will be 16 minus 2x. The width now will be the same thing, 16 minus 2x, and the height will be x. If you are going to find the volume of this figure, you have to say 16 minus 2x times another 16 minus 2x times the height of x. This is now our f of x. This is the function that we are going to work on. I hope you remember how to multiply two terms by another two terms. So we say 16 times 16 is 256. 16 times negative 2 is negative 32. Negative 2 times 16 is negative 32x. And finally, negative 2x times negative 2x is positive 4x squared. I will combine like terms. All right, now I'm going to distribute the x. And finally, I'm going to rearrange them and come up with our nice, easy looking function. We are now going to get the derivative of this function. So the derivative of 4x cubed is 12x squared. The derivative of negative 64x squared is negative 128x. And of course, the derivative of 256x is just 256. After that, we are going to find the critical number. And to find the critical number is we are going to equate the first derivative to 0. And we are going to solve for x. This is a quadratic function, so you can do this in many different ways. But for this particular function, I will divide first by 4 to make it simpler. So now I have a simpler quadratic equation. I'm now going to solve this quadratic equation by factoring. And I got the factors 3x minus 8 and x minus 8. I will now equate each factor to 0, and I will solve for x. I have the values of x as 8 over 3, and the other one is 8. Now, which of these two is acceptable? Maybe both of them are acceptable, maybe only one. Let's look at our problem again one more time. Remember, x represents the side of the square, or the dimension of the square that should be removed from each of the four corners of the cardboard. So here is the cardboard. We are going to either remove the 8 if that's possible, or remove 8/3 from each corner if it's possible. Notice that if you are going to remove a square that's 8 by 8 in every corner, nothing will remain from this cardboard. So therefore, we can say it's simply impossible to remove a square that's 8 by 8 in each of these corners. That means therefore that x equals 8 is not a solution. The only solution is that each corner have to be, or each square in each corner have to be 8/3 inches by 8/3 inches.